Hello everyone and welcome back to this YouTube channel. In today's video, we will be diving into an intriguing topic from the book Cloud-Based Remote Sensing with Google Earth Engine. Specifically, we will be exploring chapter A2.6, defining seasonality for state of no snow. Seasonal snowmelt plays a crucial role in the global ecosystem and hydrology. It replenishes the water system in rivers and helps maintain a healthy water balance. Additionally, variations in the timing of snowmelt can provide valuable insights into the effects of climate change and other environmental factors. We will try to quickly recap the quotes covered in this chapter. So let's begin. So we have the initial step here. We have the start DOY as 1 and the start and in years assigned as 2000 and 2019. So our main objective here is to determine the first day within the year when a given pixel reaches 0% snow cover. So the period will cover from 2000 to 2019. And here we have the two different variables. This will be iterated over the steps. Now let's take a closer look at this function at date bands. So this function retrieves the date property from the image and extracts the relative day and year from it. We then calculate the difference here between the date and our start date. And we also convert the date into the milliseconds. So this will be the numbers, big numbers. So just in the milliseconds. And all these variables will be set as the constant image. So we can see here ee.image.constant. So this will just make the constant images as the bands. And these are renamed as this year. So we have the calendar day of the year, we have the relative day of the year, millisecond, and the year. So this is the way to rename here. And we also have set the appropriate data types for each bands. And we also have the new property set to that image. So our milliseconds will be the new property to that image. And this is what this add date bands function is doing. So it is basically adding the constant images to the image, and also it adds the new property, that is the millisecond. Next, we set the water mask, which includes the land areas only and excludes permanent water bodies. For our analysis, we have selected the modest snow cover image collection, and you can see that this is saying this asset is depreciated. Just new version of this data might happen there. But this is just the demonstration, so this will work for now. Then we apply the mask to exclude pixels with minimal snow-covered days. So specifically, we mask out pixels that have less than 10% snow cover for at least 2 weeks in 2018. Additionally, we also remove pixels that remain snow-covered throughout the year. So these are the two important marks that we applied in this chapter. And then we finally combine the two different marks by multiplying them together. So why these two different marks are being made? It depends. Is being done by the authors themselves. So I'm just reiterating the overall process being done. So, but this is the process that has been done. So we are masking out the pixels that have less than 10% snow cover for at least 2 weeks. And we're also removing the pixels that remain snow covered throughout the year. So 2 different marks here, specifically 124 days in 2018. And then we prepare that mask into a single mask by multiplying here. And then moving on, we create the sequence of years and apply the function to it. Within this function, we filter the image collection on a yearly basis here. The resulting images are sorted by time. So this will be sorted by the time. And we use the reduce function to obtain the minimum values for each band. And we are also renaming it. And then we are applying the masking itself. So, and overall, this will be made into the final image collection. So in this function, we are filtering our image collection. We're adding the bands here, that function we developed earlier. We sort it by the time property, that was the millisecond. We reduce it to get the minimum values. We rename it. We apply that mask that was created earlier. And we also add the year property to it. And then we only want to get that area in which the pixels are content by masking itself, and we convert that into the image collection. So this is the overall process in this part. And for the visualization, so this is the visualization for the days of the Seasonality for the year 2018. So it showcases both the minimum and the maximum values. So this visualization helps us identify the first days with no snow, and the colors ranges from blue for lower values and higher for higher there will be the yellow color. So this is just for the single year. You can see this one here. We're selecting the year, and we're applying it, and we're adding it as the layer. We can also compare the results across different years. So we are subtracting 2 different images. Then we obtain a different image here that highlights the changes in the first day of no snow. So in this visualization, so it's just basically about the colors. So red represents the earlier no snow date, blue represents the later date, and white represents negligible change. So it is taking some time to appear. So basically it's about the colors only. Moreover, we can generate a slope image by plotting the year on the x-axis and first date of the year with no snow on the y-axis. So here is the way to create the slope image. We are selecting the year and this calendar day of the year, and we're applying this using function e.reducer.linear fit and selecting the scale. So this creates the slope image, And this is the same as the previous one. So different colors representing different days of the year. So the negative slopes are depicted in the red, indicating an earlier forest date of year with no snow, while blue represents a later forest day of year. So it is taking some time to load in the year, but you can inspect it and check after you run this code. And additionally, we can draw an annual mean DOI chart for the area of the interest. So we have AOI here, and we have created the buffer. So by calculating the spatial mean, so just finding the mean within that given area, we obtain this chart. So this information can be printed graphically using this function here. So this is the UI.chart.feature.by-feature. So there are different types of chart generating function. This is one of them. And so there are orphan guides for generating these types of charts. And these are very helpful for, seeing the results. And in this case, we get something like this. So the title of this chart is the Regional Mean Forest Day of Year with No Snow Cover. And what we see here is normally after 2010s, let's say 2010s, some anomalies in the days is apparent. So this is what the chart is showing. And this is it. So basically we are trying to find the day where the pixels or where the snow pixels are 0%. And for that, we create some mask. We created, we visualized the results, and we also drew this chart. And that wraps up our video for today. Please go through the chapter once, and if you have any comments or want to discuss with me, you can comment. I hope you found this information helpful and insightful. Thank you for watching, and please be around for more exciting content. Thank you.